Well, welcome to looking at rational expressions. So in this video, we're going to reduce a rational expression to lowest terms, multiply and divide rational expressions, add and subtract rational expressions, use the least common multiple method, and simplify complex rational expressions. Now remember, a rational expression is anything that can be written as a fraction. And in our instance, we're going to have some sort of polynomial or monomial on top and bottom of our fractional expression. Now at first I want to recall our cancellation property. If we have A times B divided by B times C, where B and C can't equal 0 because they would be able to be in the denominator, then we can cancel out the like terms on top and bottom. So in other words, B cancels out with B. So we'd be left with A over C. And think about it, there's different ways to think about this. Except there's a B here and a C here. It's like if I divide the top by B, what I do to the top of a fraction, I have to do to the bottom. So it'd be like dividing by B here. So that gives us 1. B divided by B is 1. B divided by B is also 1. That's one way to look at it. You could think of multiplying the numerator by 1 over B and the denominator by 1 over B, like this. Multiplying top by 1 over B, multiplying the bottom by 1 over B. Again, that would give us 1. However you think about it. But it's nice if you see the same thing on the bottom as on the top. We can, quote unquote, cancel them out. So we just got through our factoring problems. So let's take a look at a rational expression, something like this. 2x plus 2 divided by 10x squared plus 16x plus 6. And it looks like a mess there. But the first thing you want to do is you want to factor out the numerator and you want to factor out everything you can in the denominator. So in the numerator, I can see both of these terms. So I pretend like I don't have that denominator. I just look at the numerator and factor it. So I'm going to factor out a 2 and I'd be left with x plus 1. Now in the denominator is a trinomial, and we worked with those, factoring that trinomial out. So if I take this out to the side, I see if I can factor anything out of it first. And in top and bottom, I can, in here I see I can factor out a 2. So I'd be left with 5x squared plus 8x plus 3. So I've now factored out a 2. And I'm going to see if I can factor this trinomial. So remember what we did. We took the leading coefficient of the x squared term and the constant, and we multiplied those together. Then we looked for all the factors of 15. 1 and 15. 2 doesn't go into it because it's odd. 3 goes into it 5 times, and of course 4 doesn't. So here we have all the factors of 15. And we're looking for factors of 15 when added together give us a positive 8. Well, 1 plus 15 surely doesn't give us 8. That gives us 16, but this does. And why was that important? Because that showed us how we could rewrite the middle term so plus 3x plus 5x plus 3, so that factoring by grouping would work. Because see, we didn't change this expression at all. It's still 5x squared plus 8x plus 3. But we broke it up in such a way that factoring by grouping will help us to factor this under the, so that we have our integer values of our factors in here. So I can factor out an x, and I'd be left with 5x plus 3. I can see here that I can't factor anything but a 1 out. So I could say plus 1 times 5x plus 3. I write the 1 out in front just to really emphasize that when I take out their common factor of 5x plus 3, because this is one term, here's the other term, when I actually cancel and take that out, I'm left with an x plus 1 as my remaining factor in there. So now I'm going to put this inside of here, 5x plus 3, x plus 1, because they're all being multiplied together. And now I can see that cancels with that. and I'm left with 2 over 2 times 5x plus 3. But now I can cancel the 2 and the 2. So 2 goes into itself, leaving me 1. So I'm left with 1 over 5x plus 3. And that's simplifying a rational expression, that is putting it in its lowest terms. So something that we do when we have rational expressions, just like with fractions, if I have a over b and I've put those in lowest terms and c over d in lowest terms, I then can just multiply a times c and b times d, just like we do with fractions and when we multiply them. And the same will be true when we divide. If I have a over b and I put it, these are in lowest terms, and I have c over d, we know that that could be rewritten as a over b divided by c over d. And we know with division, we invert and then we multiply, so that would be d over c. So I'd have a times d over b times c. And remember, b and c cannot equal 0, and neither can d in here, because these guys, b and d, can't equal 0. So we have 3 things that can't equal 0, otherwise we'd have an undefined statement. So let's see how this works in a problem. So the first thing we want to do is we want to factor, and we try to get all common factors out. So there's nothing I can take out of here, but I do note that this is a perfect square, because this is 2 being squared, and this is twice that product. So I know that this is x minus 2 being squared. And again, how did I know that? When you look at this number and the square root of that is 2, okay? So remember how this works. It's x being squared. This is 2 being squared. And we look at 2 times x, which gives me 2x, and we multiply that by 2. That's where I get the 4x. And since it's a negative, that's why it's an x minus 2. Otherwise, I could factor it just like I factored in the previous problem. But recognizing these things makes things go a little quicker. Now I look at what I can factor out here. And I can factor out an x, and I'm left with x squared plus 1. Now I go here and I try to take out what I can there. I can pull out a 3. And I'm left with x squared plus 1. Here, factoring this out, x squared minus 3x plus 2, I note that this is x minus 1, x minus 2, because I can see that the factors of 2, which would give me a minus 3, where there's only 1 and 2, and you take their negative. So in other words, if I use the technique I used in the last problem, I'd look at the coefficient of this is 1 times 2, and the factors of that are 1 and 2, but we're looking for factors when added together give me negative. So these, when multiplied together, both of these would have to be negative, and when added give me that minus 3. So I could change this to x squared minus 1x minus 2x plus 2, and then factor by grouping. And you can see you can pull out an x minus 1, and you're left with the x minus 2. But when you start doing it a lot, you start to notice these things, and you can do it a little quicker. But this is how we would do it if I didn't see that this would be x minus 1 times x minus 2. So now that I have this, I can see which ones are in common. I see that x squared plus 1 is on the top, and an x squared plus 1 is on the bottom, so they cancel. I see that I have x minus 2 times x minus 2. So I could write that as x minus 2, x minus 2. That's exactly what x squared stands for. And I can see that one of the x minus 2's cancel out with the other one. So I'm left with a 3 on the top and an x minus 2. And on the bottom, I'm left with an x times an x minus 1. And that would be my answer in simplest form. And I can see there's no more canceling out that I can do. So let's look at a complex fraction. So I'm looking at x plus 5 divided by x squared minus 16 x squared plus 3x minus 10 over x cubed minus 8. And I know I can rewrite this as x plus 5 divided by x squared minus 16. And remember, we take this, we invert and multiply. So this would be x cubed minus 8 divided by x squared plus 3x minus 10. And now we go and we start to simplify what we can. So my next step would be, this is x plus 5. I know here is a perfect square. That's x plus 4, x minus 4. This is a cube, and breaking up a cube, if you remember, it's that special one where I see that it's x minus, a cubed minus another cube. This a cubed minus b cubed. So the first thing would be a minus b. So in my a here is x being cubed, and my b is 2 being cubed. That's what gives you 8. So I know this is going to be x minus 2. What comes next is your a squared. So that would be a being squared is x being squared. Then we look at their product, 2 times x plus ab. So plus x and 2. So that would be a 2x. And then it would be plus the last, b being squared. So b being squared would be a plus. 2 squared is 4. So I'd have x minus 2, x squared, then twice their not twice their product, but their product, 2, but just the x and the 2, so 2x, and then that being squared plus 4. Divide that by, and then factoring this out, the factors of negative 10 when added together give me 3. So I know it's going to be x plus 5, x minus 2, because 5 plus 2 gives me the minus 3, and 5 times negative 2 gives me 10. Or we could have done what we did up here, where I take off to the side this. I look at the coefficient here and that, and I say 1 times negative 10, that's negative 10. And I look for factors of 10, but not just 10, but negative 10. So I've got to figure out which one of my factors get the negative. And since that's a plus 3x, that means my larger factors have to be positive and my smaller factors have to be negative. And we're looking for those factors when added together give me minus 3. Well, when I add 5 plus this negative 2, that's where I get that negative 3. That tells me how to rewrite the middle term. So I say x squared minus 2x plus 5x minus 10, excuse me. And now I factor by grouping. So I look at the first 2 terms, and then I look at the second 2 terms. So out of the first term, I take out an x, and I'm left with x minus 2. In the second, I take out a 5, and I'm left with an x minus 2. And there's my common factor, so I pull it out, and I'm left with the x plus 5, just like I saw in here. Now that I have this and this all being multiplied together, I can now cancel things out. Well, I see that x minus 2 cancels out with x minus 2. I see that x plus 5 cancels out with x plus 5. Now I look at this, and the one thing I didn't factor was that, and I should have, because this is but when you look at this, you go, well, what factors of 4 when added together give me 2x? And it doesn't, you can't factor that any further. So that, I should have looked at it, but I knew that when you factor it, that's as factored as you could get. But you always want to take a look to see if anything can factor, but that one didn't. So I'm left with on the top, x squared plus 2x plus 4 divided by x plus 4, x minus 4. Now this is true, but before we give this as our answer, we have to look back and we got to make sure none of these factors could be 0, in here. So we have to say it's this if x doesn't equal minus 5, if x doesn't equal 2, because if x equal 2, then this would be 0. X cannot equal 4, and x cannot equal x cannot equal negative 4. So we have to make sure that each step along the way, any of the x values that could give us 0 in the denominator are not part of our domain. So we have to pull them out of our domain. So this is true for all real numbers except when x equal 5. If x equal negative 5, let me make that clear because it's hard to see that. So this is true everywhere except for when x equal negative 5, 2, 4, and minus 4. When it does, then this function has no value. So make sure that you write your stipulations on there when you get finished. So now we extend this a little bit further if we should have a problem where we're adding or subtracting. So when we start out and we look at this, we have to make sure we have a common denominator in order for us to add or subtract. Just like a regular fraction, we'd have to have two, let's say that we had 7/5 minus 2/5. In order for us to do this, we have to have a common denominator, and then we can subtract or add the numerator. Remember how that worked? So that would be 1. Or if I had 7/8 plus 3/8, that would be 10/8 because we had that common denominator. So when we look at this, we say, yeah, we do have that common denominator. So 3x plus 4, and then I'd have 5x minus 3 minus, and in parentheses, I put x plus 1. Be careful because you've got to make sure you minus everything that's in that numerator. So this would become 5x minus 3. Distribute the minus sign through. So that's minus x minus 1. 3x plus 4. Now I can add like terms in my numerator. That'd be 5x minus x gives me 4x. Negative 3 minus 1 minus 4 over 3x plus 4. Now I factor out the 4. X minus 1, 3x plus 4. And I've answered the question. And we have to be a little careful when we look at certain problems. So let's look at this. They look like they're the same, but these are not. This is x minus 1, and that's 1 minus x. We have to get a common denominator. So I can note, if I take this and rearrange it, negative x plus 1, and I factor out a minus 1, that would become x minus 1, and now they would be the same. So this is kind of a little trick when you have a problem like this, and that's why I kind of put this in there so we could see it. So in here, I would write 6 divided by x minus 1 plus x over negative x minus 1, right? Well, that just made that 6 over x minus 1. Remember, that's like my negative 1, so we're just going to subtract x over x minus 1. So we now have a common denominator. We add the numerator, but in this case we're going to subtract because we're subtracting. And this would be our answer, 6 minus x divided by x minus 1, where x cannot equal 1. Now, as things get even a little more involved, let's look at these two rational expressions, a over b and c over d, where b and d both can equal 0. If I have a over b plus c over d, just like just like regular fractions, we would get a common denominator. And let's say these are in lowest terms, bd here over a times d. So if I multiply top and bottom by d, and this one top and bottom by b, bc over bd, we now have that common denominator. And now I can add the two numerators because I've got the denominator being common. Okay, and if you did subtraction, it would be the same thing. If I had a over b minus c over d, I get that least common multiple. Let's say that we've reduced everything, and I could do a over b, and I multiply both top and bottom by d, but I'm subtracting this time. Multiply c over d times b, both numerator and denominator. I'd have AD minus CB, and BD and DB obviously are the same, so that's BD. So we could now add or subtract the numerator. So let's see how that would look in practice with a problem. So looking at this problem and working it, first off we say x cannot equal 4 and x cannot equal negative 3. Otherwise, we would have 0 in the denominator, so that would be true. So the next thing we have to do is we have to get a common denominator. And the least common multiple between x minus 4 and x plus 3 is x minus 4 times x plus 3. So I'm going to take my first term and I'm going to multiply it by x plus 3. I'm going to take the second term and multiply top and bottom by x minus 4. So I'm going to multiply top and bottom by x minus 4. And I do this in this way so that the denominator looks identical. And then this, since that's 2x, just put it out in front. So now I'd have the common denominator of x minus 4, x plus 3. I leave it like that just in case somehow I can simplify in the end. Never really sure, but I always want to keep them so that I let people know that I've got things in lowest terms. Then at the top I have 3x squared plus, multiplying that out, 3x squared plus 3x times 3 is 9x plus 2x times x, which would be 2x squared, and then negative 8x. And now I add my like terms in the numerator. 3x plus 2x is 5x squared. 9x minus 8x is just an x. Divided by x minus 4, x plus 3. But I'm not done yet. I need to factor that out just to be clear. And I'd have 5x plus 1 over x minus 4 times x plus 3. And I'm finished. Let's look at another problem. So if I have x over x squared minus 1, and I'm going to subtract from that 1 over x. To be clear, x cannot equal 1. X cannot equal negative 1 because both negative 1 and 1 would make that 0. And x cannot equal 0. So I have to think when I'm doing this to get the least common denominator, I'm going to first factor both of these denominators to see what I have. Well, this one's already, I can't factor that anymore, but I can factor this one. So I'd have x plus 1, x minus 1, minus 1 over x. Therefore, I can clearly see what x can and cannot answer here. And now to get the common denominator between both of these, I'm going to multiply this first term, top and bottom, by x. And then for my second term, I'm going to multiply top and bottom by x plus 1, x minus 1. And now I try to collect terms. So I have x squared minus, and now I'm going to have to multiply these out because I have I want to see if my x squared could somehow cancel, or I could cancel or have something. So in here, make sure, since there's a minus sign there, when I multiply this out, it's x squared. And look what it is, x squared plus 1, x squared minus 1. We know well that's x squared minus 1. And on the bottom, I have x times x plus 1 times x minus 1. Then on the top, x squared minus x squared plus x. Remember, you have to distribute that sign into there where all the signs change, over x times x plus 1, x minus 1. And the x squared minus x squared minus x squared cancels each other, and I'm left with 1 over x times x plus 1, x minus 1. So now we're going to look at the least common multiple to add rationals. And what does that mean? Well, let's look at this problem here. So in here, I have to factor both of the denominators and to see if there's any common multiple. So I'm not, having to multiply a whole lot of different factors. So I know that this is the difference of two squares. So I know I can rewrite this as x plus 2, x minus 2. Now I have to look, can I factor the bottom? And I can. It's going to be x plus 3, x plus 2, or x plus 2 times x plus 3. How did I know that so quickly? Because I know 2 times 3 are factors that give me 6, but when added together give me 5. And when I don't have a coefficient to that x squared term, those would go in there. But you could show that to yourself again by factoring. 1 times 6 is 6, factors of 6. Since it's positive, 2 of them adding together give positive, means both factors have to be positive. And this is the one when added together give me 5. And I could rearrange, I could rewrite that 5 by 2x plus 3x. And then by grouping, pull out the x, I'd be left with x plus 2. Pull out the 3, I'm left with x plus 2. I factor out my x plus 2, and I'm left with the x plus 3. So this technique always works, but you can by inspection figure it out also. Now, once I have that, now I look, what do I have in common? Both of them have this, so I don't have to multiply this one by x plus 2, x minus 2, x plus 2, x minus 2. It would be redundant because I have it both in both of these. So all I need to do is the ones that they don't have in common. So this is what they don't have in common here, and this is the one they don't have in common here, over here. So I'm going to multiply the first factor by this x plus 3, x plus 3, and then the second factor I'm going to multiply by the x minus 2, x minus 2. And now I have that common denominator on the bottom. So I didn't have to do so much multiplication. So I'm going to have x squared, distribute that through, plus 3x, plus, and now I have my x squared, my negative 2x, plus x, minus 2. And on the bottom, I keep these just like they are. I don't mess around with them. And I keep them, it doesn't matter which order you put them in. I'm just going to put them in with the first one, but I know I've got my x plus 2, my x minus 2, and my x plus 3. And now I'm going to put together in the numerator things that are in common. X squared minus 2x. That would be minus x, excuse me. Negative 2x plus x is minus x, minus 2, all over my x plus 2, x minus 2, x plus 3. And now I put my like terms together. I have 2x squares, then 3x minus x gives me minus 2x, and then I have this negative 2 over x plus 2, x minus 2, x plus 3. And now I can pull out a 2 on the top, and I'd have x squared minus x minus 1 all over this. And I'm done because there's no way to find factors of negative 1 that would give me a minus 1. So I know that I have my answer in lowest terms, where I also know that, looking back on here, x cannot equal 2, x cannot equal negative 2, and x cannot equal negative 3. But sorry about that. I just noticed that should be a plus there. So this should be a plus in there. So it should be 2 times x squared plus x minus x all over x minus 2, x plus 2 times x plus 3. Sorry about that. Slight mistake. So once again, when cleaning this up, we just add our like terms. So I just x squared plus x squared gave me the 2x squared. I had 3x minus the 2x. Well, negative 2x plus x gave me the minus x. So 3x minus the x gave me the positive 2x. And then negative 2. And once I factor out my 2, I can see that there's nothing else that can factor. And I'm finished. Then we have super complex fractions where you could have something like this where you have a complex fraction in the numerator and a complex fraction in the denominator. And there's different ways to attack it. Some people will multiply top and bottom by the common denominator between the 3, the x, and the 6. Other people will do all the operations in the numerator and the denominator. Either way, you'll get the right answer. So the first thing I want to do is I want to note that, first of all, x can't be equal to 0. I know that. And that x plus 4 can't equal to, x can't equal to negative 4, or we'd have a 0 here. So that's the first thing that we do. So I could go and do it the first way that I said. So I pretend like I don't have this, and I just work with that and try to get this into, this addition first. So I'm going to multiply this first by x, and I'd multiply the second by 3 over 3, so 2 times 3 over 3x. Then I look just at the bottom and I say, well, there's not much I can do there. I'm just going to leave it as x plus 4 divided by 6. That's all put together. So this one would give me x plus 6 over 3x on the top, and then the x plus 4 over 6 on the bottom. So I had my common denominator of 3x, and then I said x plus the 6 there. Now I'm ready to invert and multiply. So I'd have the x plus 6 over 3x times 6 over x plus 4 on the bottom. Putting this together, I'd have 6 times x plus 6, 3x times x plus 4. But I'm still not done because I see that 3 can go into 6. 3 into itself goes 1 times, 3 into 6 goes 2. And I'm left with 2 times x plus 6 over x times x plus 4. So that's the first way you could do it. Now let's look at the second way that I told you, that if I multiplied top and bottom by the least common multiple between 3x and 6, and you'll see that we get the same answer. So the 3x and 6, the least common multiple of that would be, for all of these, because remember that's 3, that's 6, and this is 2 times 3. So in order for all of these to be, to see each of the different factors in there, I need to see a 3, I need to see an x, and in this one, 3 is already done, but I need to see a 2. So I'd have to multiply everything by a 6x, would be the least common multiple between 3x and 6. So I'm going to take my problem, and I'm going to multiply top and bottom by this 6x. When I do that, I'd say 6x times 1/3 would be 6x over 3 plus 6x times 2 over x. And then in the denominator, I have 6x times x plus 4 over 6. And I can clean some things up. Like in here, I see 3 goes into 6, leaving me 2. So I have 2x plus x goes into x, leaving me 6 times 2, which is 12. On the denominator, 6 goes into 6, and there's a x times x plus 4 here. And then I have one more step in here. I can take out a 2, and I'm left with x plus 6. And then in the denominator, x times x plus 4. Can't clean anything else up. And look, both answers are the same. Here's our wrap up. We reduced a rational expression to lowest terms. We multiplied and divided rational expressions. We added and subtracted them. We used the least common multiple method. And then we simplified complex rational expressions. And thank you all for watching. Bye.